Hello, hello, hello. We are going to be doing climate feedback loops and tipping points. And this is in relationship to chapter 2 of the book Weird Weather, which is also about tipping points. First, a little review. So, what have we learned so far about the greenhouse effect? First of all, the main greenhouse gases are, and make sure that you know this, they are carbon dioxide and methane. Nitrous oxide is also there, but it's less important. The two main ones I want you to know are carbon dioxide and methane. So why is it that we have more of carbon dioxide and methane in our atmosphere since the 1850s? What is it that happened in the 1850s to change things on this planet? And the answer to that is we saw the Industrial Revolution mean that humans started to burn coal and oil in a massive amount, and that burning of the fossil fuels, coal, oil in the form of various forms of fuel, have pumped up huge amounts of carbon dioxide into the atmosphere and created a much thicker layer around the Earth than ever existed primarily. So it's 1850s saw the rise of the Industrial Revolution, the invention of the steam engine, and the discovery of the use of coal and related products for creating electricity later in that century. So that's what happened. It was the Industrial Revolution that brought us the massive change in our Earth's atmosphere. So the main fossil fuels are, first of all, coal. That is a huge one, particularly for producing electricity. We also have oil, which is converted into various products like gasoline, like diesel, like jet fuel. Oil is also converted into various heating oils for houses and other buildings to keep them warm. On top of that, we have gas. So this is not gasoline, but it is gas. Natural gas is sometimes called. It is in the United States used for cooking fuel in gas stoves. It is also used to power cars and to power other forms of transport as well. So the three main fossil fuels are coal, oil, and gas. Gas is not gasoline. Gas is sometimes called natural gas, liquefied petroleum gas, those various forms of gas on top of oil and coal. So what is the primary source of unnatural CO2 in our atmosphere? The primary source is burning coal for electricity and burning gasoline and diesel for transportation. But those are not the only forms of unnatural CO2 in the atmosphere. What is the primary source of unnatural methane in the atmosphere? That is primarily from agriculture, particularly from raising beef and dairy. So beef and its related products of milk and cheeses and other forms of dairy. Those are the primary contributors to methane in the atmosphere. That as well as the rot from landfills. So all of the food that we don't eat and that then goes into the garbage that then starts to rot lets off methane, which ultimately makes its way up into the atmosphere, and that's a major contribution to a greenhouse effect that's causing us climate change and global warming. So when too many greenhouse gases build up in the atmosphere, what does it cause? Just answered that. It causes, that thickened atmosphere causes global warming. Why is that? Because carbon and methane in particular in the atmosphere don't allow out infrared light that the Earth absorbs from the sun. And when that infrared light gets either kept within the atmosphere or bounced back onto the Earth, it warms up the planet. So the effect of too many greenhouse gases in the atmosphere is global warming. So as the atmosphere warms, what are the consequences for the planet? The consequences are climate change, which includes things like increased hurricanes and worse hurricanes, increased droughts, increased forest fires, increased heat waves, sea level rise, and all of the concomitant problems. There's a whole host of problems that come along with climate change as a result of global warming, which is caused by the greenhouse effect, which is worsened by the increase of greenhouse gases, which are caused by burning fossil fuels. So we go from fossil fuels to greenhouse gas emissions to the greenhouse effect, which causes global warming, which causes climate change, right? That is the order of causality in those terms. And so make sure you can differentiate those, make sure you know how they're related to each other, what causes what. Okay, that's it for our quick review. Let's get into the feedback loops and tipping points. So first of all, it's important to know, and you probably already do, but this is review for anyone who doesn't know or has forgotten, that naturally the Earth can absorb a great deal of carbon out of the atmosphere and does do that as part of the life cycle. So the carbon in the atmosphere circulates through plants, which are primarily composed of carbon, and it circulates through ocean life, particularly in the form of plankton and plants that live in the ocean. So that there's this constant cycle of plants and animals pulling carbon out of the atmosphere, particularly plants, and then releasing it back when they decompose, or when they, for animals, when they respirate, so when they breathe, the carbon goes back out. For plants, when they die, the carbon can be released back into the atmosphere. So that's a normal part of a healthy planet. It's important to understand that, to understand how tipping points work. So what are tipping points? Tipping points are where we can get to with climate change that then becomes irreversible. So that is where climate change gets so bad that the planet can no longer operate in its normal, natural way. And then the planet itself starts to essentially decompose or die, and it starts to produce its own forms of carbon and methane and pump them into the atmosphere. So a tipping point is where the Earth can no longer withstand all of the carbon and methane that are in the atmosphere, and it can no longer have its normal carbon cycle that is what sustains life. So the more carbon and methane that we pump into the atmosphere, then the closer that we get to a point at which the life cycle on Earth is no longer tenable. And at that point, the Earth itself starts to pump out more and more carbon and methane, and that is not us doing it through our own ongoing production of electricity, or driving of our vehicles, or eating our food, consuming our normal products. That's not us doing it anymore. It starts to be the Earth itself that produces those forms of carbon and methane. It's essentially a process of ecological collapse where the Earth is no longer able to breathe and live and cycle in the way that it naturally does. So basically, this is where the planet and its ecological systems that normally would suck in forms of carbon, retain them, hold them, and then release them naturally in slow ways over time, when that no longer happens. So as you read in the book, soil is very good at pulling carbon into it in the form of dead plants that basically are kept cool enough in the soil to not decompose. But when soil starts to warm up, then those plants do decompose. The temperature gets such that they start to rot, and then the soil starts to release carbon and methane into the atmosphere at higher rates than it did before it warmed up. Similarly, when forests start to die, or thick vegetation anywhere, whether it's trees or not, then the world cannot pull in the carbon that is currently in the atmosphere. So if those trees can't survive because the temperatures are too hot, or they're not getting the normal water that they get, the rainfall that they're used to getting, and they start to die, then they release their carbon, and they can't pull more carbon out in the way that they normally would because of the carbon cycle. Similarly, with forests, oceans are the same. Once the ocean starts to have absorbed way too much carbon, and once it starts to heat up to a certain level that the ocean life within it can no longer live properly, then it starts to no longer pull carbon in through the life cycle, the carbon cycle, and it also starts to release carbon and methane through the death of the plant and animal life and phytoplankton that's inside it. So one of the primary places that this is already happening is at the North Pole in the form of the thawing of permafrost. So you'll remember from the last video, I showed you that the temperatures are warming up at the ice caps and along the North Pole much faster than they are anywhere else on the planet. And what that has meant is that stretches of land that have for many, many millennia been covered in what's called permafrost, or this, it's sort of snowy combination of soil and snow that animals can actually scrape through to get to plants underneath sometimes. But as the temperatures are rising at the North Pole and the ice caps and the areas around them, then the permafrost that covers places like northern Scandinavia and Russia, northern Russia, Siberia, and that large stretch across the northern parts of the world, so northern Canada, as all of that starts to warm up, the permafrost, it's not quite snow, but this interesting thing that exists up there called permafrost starts to melt, and what's underneath it is 8 to 10 feet of vegetation that it has essentially been thawing and keeping cold, keeping it refrigerated for millennia. So as it thaws, then all of that vegetation that has been trapped underneath it is starting to begin to decay, and as it decays, it is releasing methane into the atmosphere. And so the very process of us warming up the permafrost and making the permafrost melt means that then the earth itself is starting to contribute more methane into the atmosphere that humans are not contributing. So when we get to a point where we push the earth past its normal limits, the earth itself starts to contribute to climate change. This is true also of rainforests, which are a major part of the carbon cycle, particularly the Amazon forest. The Amazon forest is like the lungs of the planet. It pulls in a huge amount of carbon and sequesters it or holds it in the form of leaves and branches and tree trunks and roots. And as the Amazon rainforest is being hit with higher temperatures and drought, all caused by climate change, then the trees start to die, and then they actually end up releasing more carbon into the atmosphere, particularly in the form of forest fires, which you can see from this image below. There are forest fires in the Amazon that are being set intentionally by farmers and others who want to use the land or exploit the area in various ways, farmers and miners. So they are actually clearing the Amazon rainforest for their own purposes. But in addition to that, there's die-off and fires in the Amazon that are not even being set by humans, but that are being caused by the stress that the forest is right now experiencing. So that the Amazon, our main source of forest on the planet, is in extreme stress and is beginning to die right now. So droughts more generally, not just in the Amazon, but all over the world, contribute to carbon emissions when we have these chaotic weather patterns that climate change brings us, that then mean we have too much rainfall sometimes and too little rainfall other times, that then cause drought. We start to get these large areas that can no longer sustain plants in the same way. And then that plant life that is not able to grow because of the drought means that there's less carbon pulled out of the atmosphere. And there's also then soil erosion and soil death that makes it more difficult for the plants to reestablish themselves even when it rains later on. So droughts, and particularly their consequences for soil erosion and for soil death, are an ongoing problem that we're going to have to face and start to grapple with as we try and hold on to the healthy ecology that we need for the planet to sustain itself. So in relationship to drought, of course, not surprisingly, we see a lot of fires that spring up in areas that are devastated by drought, and or even not just drought, but decreased rainfall for a long time. So although you don't have to have too much drought to start to stress your plants out enough that they will actually be susceptible to fire in a way that they wouldn't have been naturally and normally. So we have seen this massive increase in forest fires around the globe because of drier conditions. And that adds this extra layer on top of drought that doesn't allow in the sequestration of carbon by pulling it out of the atmosphere. When we have forest fires, then you're actually emitting massive amounts of carbon into the atmosphere by burning those trees, because those trees, remember, are basically carbon. They are carbon in the form of leaves and roots and trunks and branches, and when that all burns, it releases that in the form of carbon dioxide into the atmosphere. So we have had record-setting fire recently. 2020, 2021, 2023, 2024 have all been years that have been seen massive levels of fire. In 2023, 12 million hectares, that's roughly the size of the country of Nicaragua, burned, which is higher than the previous record by about 24%. So we're seeing massive increases in the size of fires. There's also been regional hotspots that we have witnessed. So extreme wildfire is a particular problem in Canada, which contains vast stretches of boreal forests, that is like cold forests, that have been burning for the last few years every summer and wafting huge amounts of smoke down into the United States. But Canada has been just like one big forest fire, one big stretch of smoke in recent years. And this has seen 1/4 of all tree cover loss globally in 2023. It's been extreme. So on top of forest fires and droughts and problems with permafrost releasing methane into the atmosphere. Another form of a feedback loop where our carbon dioxide emissions starts to cause the Earth to also emit carbon dioxide, so that loop starts to take place. There is a very important term that I'd like you to learn, which is called the albedo effect. So the albedo means white, and the albedo effect is all of the snow and the ice caps and the permafrost and the glaciers, anything that is white and or lighter colored on the surface of the planet will actually reflect sunlight back into the atmosphere, and that helps us actually keep some of the sun's rays out of our system. But as those ice caps and ice sheets and permafrost and glaciers start to melt with higher temperatures from global warming, then they turn into darker surfaces, whether that's water or whether they start to melt and reveal darker earth underneath. And those darker surfaces cannot reflect the sun's rays back into the atmosphere. So when we start to get the melting of all of this ice across the planet, then the planet becomes less able to reflect back the sun's rays, and it instead starts to absorb more of the sun's rays. So we get another feedback loop. By us heating the planet up, then the planet itself starts to heat up more. Again, our actions causing a loop that then pushes the Earth in the same direction as well. So the albedo effect is a decrease in the Earth's capacity to reflect sunlight caused by the melting of any large ice sheet that is then melted from global warming. So I mentioned that oceans will pull in a lot of carbon through the normal life cycle. And warming oceans definitely make it harder for life to survive, because life has a very narrow range of temperatures in which it can survive. Similarly with humans, if you think about what is an acceptable range of temperatures for us, particularly when we are small, it's actually the smaller a plant or an animal is, the narrower its range of temperatures that it can naturally withstand, or that are naturally useful for it to be able to grow and reproduce itself. So warming temperatures in the ocean are already a problem. But as I explained in the last video, acidity in the ocean is another problem that kills the animal life as well, if those animals have shells. So warming oceans kill coral reefs because they can't tolerate that kind of heat. And the coral reefs are the source for the greatest biodiversity in the oceans. So we then kill out much of the biodiversity, that is the range of species that the oceans sustain, which then cause disruptions in the life cycles overall in the oceans, and then start to see the collapse of the possibility for the ocean to sustain normal life. And as the oceans start to die off, they not only cannot pull in more carbon, but they start to release more carbon as well, carbon and methane, as they decompose, just like the forests on the Earth as well. These are essentially, you can think of them as forests under the ocean. So another thing that is not happening at this right now in the same way that some of the rest of these things are happening already, but that is mentioned in the book, which could happen if we continue to see increased temperatures in the oceans, or increased melting of the ice sheets and Greenland, which is largely ice. What we could potentially see if that happens is something called methane hydrates, which are currently under the ocean and held in a stable form because of the cold temperature and the pressure of the ocean on them. But if the ice sheets melt and that pressure is shifted and the temperatures rise, then the methane hydrates will no longer be stably stored at the bottom of the ocean, and they will start to erupt with methane out of the ocean and into the atmosphere in ways that will then create not only a thicker atmosphere, but disrupt the life cycles of the ocean itself. That, if we would get to that point, we will see a great deal of ecological destruction on the planet, as has been documented for eras in the past. So all of these climate feedback loops interact with each other. As one ecological system starts to die, it actually contributes to other ecological systems dying because all of these systems are interrelated. And the planet as a whole is dependent on every other aspect of the planet in order to maintain the life balance that creates this special biome that we get to live in. So some of the things that our production of carbon and methane and pumping them into the atmosphere can impact from the earth, and then the earth starts to itself change, is sea ice can no longer form, which then does not allow the sunlight from the sunlight to be reflected back in the same way, and then absorbs more heat into our planet. Similarly, less snow cover means less albedo effect, but also more importantly for our purposes here, less snow cover and fewer glaciers or less snowpack that heats up and melts more quickly means that we don't get the water trickle that we need to be able to feed our streams and rivers and nourish us, our societies downhill of them during the summer. Instead, it all comes rushing down in the spring, and there's nothing left to tap into in the summer, which is particularly true for us here in California, since most of our water comes from the snowpack in the Sierra Nevadas. So if that snowpack melts too quickly, it gives us a drought later in the summer. And increased permafrost melting means that we start to see methane spewing into the atmosphere from what's underneath the permafrost, plus the permafrost can no longer have that albedo effect. As we start to see things drying out around the world, we get these wildfires, and those wildfires pump tons of CO2 into the atmosphere. As the climate changes, we start to get changing patterns of clouds, and those clouds also create an albedo effect and reflect the sun's rays back into space. So changing cloud patterns and fewer clouds mean that we get less of an albedo effect. As temperatures rise, we get an increase in what's called desertification, or the increasing of the desert, where the soils start to erode, the soils start to die, the plants can't live in the same way, and then we start to get this increase of areas where plants and animals are no longer able to survive. And forest dieback means that we cannot sequester as much carbon as before, so we have more carbon in the atmosphere that comes from forests dying. And as we know from the book, also dying trees or heat-stressed trees are also more susceptible to beetles, pine beetles, spruce beetles, a variety of beetles that then, and true also in other parts of the world, where insects start to take apart the forests in ways because those forests are less able to resist them. And then we start to get not only fires, but other forms of decay that don't allow the forest to sequester carbon and start to actually emit more carbon and methane into the atmosphere. So the idea of a feedback loop, again, is we are producing carbon and methane through our consumption patterns, and those then are causing the earth to change in ways that the earth also starts to pump out more carbon and more methane in ways that we can no longer control, because we can decide to stop using gasoline and diesel and coal and stop eating methane producing things. We can really change the way that we live as humans, but if we push the planet to such a point that it's producing methane and carbon in massive forms, we won't be able to stop what the earth is doing. So that's why it's called a tipping point, because it pushes us to a point where even if we changed our behavior, it wouldn't matter anymore, because the earth is already emitting more and more carbon and methane in ways that are making the earth hotter and hotter and hotter. So it would get beyond our control. So how hot is it actually going to get? Scientists have told us that we should stay beneath 2 degrees Celsius in order to maintain a tolerable form of life on this planet. What is really kind of shocking is that we are already between 1.25 or 1.5 degrees Celsius. So we are already very close to that point. And we're already experiencing massive hurricanes, massive droughts, massive forest fires, massive seacoast rising and storm surges. So we're already experiencing all of these problems of climate change, and we haven't even got to 2 degrees yet. So things are going to get much worse at 2 degrees. And 2 degrees is actually difficult for us to stay at. Right now, as you can see from this graph, models are showing that it's possible for us to get quite a bit higher than 2 degrees Celsius based on our current trajectories, that we have not reined in our fossil fuel emission, fossil fuel consumption, and our greenhouse gas emissions, and we are continuing to warm the planet as a result. But you can see that where we are right now is already not anywhere near how bad things can get going forward, where it's possible for us to get, and that some models show us getting into even as high as 8.5 degrees Celsius, well beyond what we already are today. But right now we are definitely on track to get past 2 degrees Celsius between 2030 and 2050, so just around the corner. So every little degree or part of a degree matters a great deal to the risks for our planet, for our ecosystems, and for us as humans who are experiencing droughts and floods and forest fires and hurricanes. So as you can see from this slide, there are a whole variety of potential outcomes and reasons for concern in terms of both what people will experience, what our economies will experience, what our ecosystems will experience across the globe. So pause this for a second and take a minute to read these graphs closely. So even a tiny half degree will actually make things much, much worse. So we're already approximately at 1.5 degrees Celsius, and getting just a half degree hotter will make extreme heat almost 3 times worse. It will make our sea ice Arctic problem 10 times worse. It will make sea levels rise 0.06 meters worse, which doesn't sound like a lot, but it's actually significant in terms of how far inland that comes. For species loss, it would make it 2 times worse, and that's for vertebrates. And for insects, it would make it 3 times worse, which insects are one of the major food sources for the life cycle on top of the land, and so insects dying would start to bottom out the life cycles more generally for the environments across the globe. So just a tiny bit of temperature change has massive ramifications. So if we go even further, think of what we'll be experiencing then, especially if you think about what we're already experiencing now and how things will be when we hit 2 degrees in a few more years.